In our video Intro to Scattered Plots, we talked about what a scatter plot was and the three different types of correlations that scatter plots can have. Today we're going to talk about a line of fit, sometimes also referred to the line of best fit. Well, the line of fit is a line on a scatter plot that seems to pass close to most of the data points. It's not going to cross exactly through all of them, but you're trying to get one that is just an average of all those points, as close to as many points as you can get it. Okay, when making a line of fit, well, the first thing you need is a scatter plot, and then we're going to determine if any relationship exists in the data. Is there a positive correlation, a negative correlation? Because if there's no correlation, there's no line of fit. Okay, once we determine that there is either a positive or a negative correlation, our next step would be to draw a line that seems to pass close to most of the data points. Once we have that done, we're going to use 2 points on the line of fit to write an equation for the line. We know a couple of different ways to do this. One is to find the slope and then plug it into point slope. Another one would be to find the slope and then plug it into slope-intercept form and solve for b. Step 4 would be that we can use this line of fit or its equation to make predictions. All right, let's just take a look at an example of one of these. Okay, this scatter plot shows the relationship between the years since 1988 and the vertical drop in feet of roller coasters. Okay, a line of fit has already been added, and you can see the line doesn't go through each point, but it seems to pass close to most all the points. Okay, and this line of fit passes close to the ordered pair 2, 150, because it's real close right there, and it also passes close to 12, 300, as you can see there. All right. Now, we can use these points to write the equation for the line of fit. Well, the first thing we need is slope, so I'm going to plug it into the slope equation. Remember, the slope equation is m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So when I plug in my y's, on top we'll have 300 minus 150. On bottom we'll have 12 minus 2, which gives us a slope of 15. Now I can take this slope of 15 and plug it into my slope-intercept formula. So I'm going to replace the m with 15, and I'm going to replace the x and y with one of the ordered pairs. I chose to use 2, 150. Now I'm just going to try to isolate b. So the first thing I need to do is simplify 15 times 2. Well, that gives us 150 is equal to 30 plus b. Since they're adding 30 and b, I need to subtract 30 from both sides. When we do that, we see that 120 is equal to b. So now I know my slope, which is 15. I know my y-intercept, which is 120. So I can plug it in and write the equation y is equal to 15x plus 120. This is the slope-intercept form of the equation that represents the line of fit for our table here, or for our graph. Now let's make a prediction based on that. Okay, let's make a prediction on what will be the vertical drop 30 years after 1988. Well, we have our slope-intercept form equation here. We can plug in 30 for x because that represents the number of years. When I do that, I have y is equal to 15 times 30 plus 120. Since y is already isolated, we're just going to go ahead and simplify on the right side of this equation. I can do 15 times 30, which is 450. So now we have y is equal to 450 plus 120. We can go ahead and do the addition, and we get y is equal to 570. And we know that we're talking about the vertical drop on roller coasters. So that means, according to the table or our line of fit, 30 years after 1988, the vertical drop of a roller coaster will be 570 feet. I hope that gives you just a little bit of insight on how to use a line of fit and how to make a line of fit and how to use it to make a prediction. If you have any questions, be sure to reach out and have a good one.